There are things that modern scientists figured out with satellites, supercomputers, and billion-dollar telescopes that certain ancient civilizations already knew, thousands of years ago, with no electricity, no instruments, no nothing. And the scary part is not just that they knew these things, it is how precisely they knew them. We are talking about people who calculated the rotation of the Earth to within fractions of a second. People who tracked Jupiter using what is essentially primitive calculus. People who built machines that could predict solar eclipses for decades into the future. These were not lucky guesses. Today we are counting down the top 10 civilizations that blew the minds of modern scientists the most, starting with the one that absolutely nobody saw coming. In 1054 AD, something appeared in the sky so bright it could be seen in broad daylight, not just at night, in the middle of the day, for 23 days straight. Chinese astronomers documented it meticulously, noting its exact position, its brightness, and how long it stayed visible. Centuries later, when modern astronomers pointed their telescopes at the exact spot those ancient records described, they found the Crab Nebula, the remnant of a star that had exploded roughly 6,500 light years from Earth. The Chinese were among the first to record supernova, and the most famous is that supernova of 1054. What makes this genuinely jaw-dropping is that modern scientists still use those ancient Chinese notes today to calculate the age and expansion rate of that nebula. An ancient civilization documented a cosmic explosion so accurately that their records are still scientifically useful 1,000 years later. Most people know the Greeks figured out the Earth was round. What most people do not know is how insanely accurate they actually got. The mathematician Eratosthenes, around 240 BC, used 2 sticks, the distance between 2 Egyptian cities, and the angle of sunlight at noon to calculate the circumference of Earth. His answer came out to roughly 39,000 to 40,000 kilometers, and the actual circumference of the Earth is about 40,075 kilometers. He was almost exactly right, over 2,200 years ago, with just 2 sticks and a dream. One of the key pieces of evidence the Greeks used for a round Earth was observing that during a lunar eclipse, the shadow Earth casts on the moon is always curved, something only possible if the Earth itself is spherical. I am looking at you, flat earthers. I'm not judging, I'm just saying, let's think about it, okay? Let's open the floor. While Europe later spent centuries arguing about the shape of Earth, I mean, look at us today, Greek scholars had already done the math and moved on. In 499 AD, an astronomer named Aryabhata, working in what is now Bihar, India, published a text called the Aryabhatiya. In it, he argued that the apparent movement of stars across the sky was not because the stars were moving, but because the Earth itself was rotating on its axis. He did not stop there. He calculated the sidereal rotation of the Earth as 23 hours, 56 minutes, and 4.1 seconds. The modern accepted value is 23 hours, 56 minutes, and 4.091 seconds. He was off by less than 1/10 of a second in the 5th century. He also correctly explained that the moon shines by reflecting sunlight and gave accurate scientific explanations for both solar and lunar eclipses. Europe would not officially accept that the Earth rotates for another 1,000 years after he had already written that number down. In 2016, a historian named Matthew Ostendriver was going through clay tablets at the British Museum, tablets that had been sitting in storage since the 1880s, when he found something that completely rewrote the history books. The tablets proved that ancient Babylonian astronomers used a complex geometrical model resembling a rudimentary form of integral calculus to calculate the path of Jupiter. Historians had believed this type of computation was first developed in 14th century Europe. These tablets, written between 350 and 50 BC, are the earliest known examples of the technique, predating European scholars by at least 1,400 years. They were doing this specifically to track Jupiter because Jupiter represented their god, Marduk, and they believed predicting its position would let them forecast grain prices and floods. So they did not invent calculus out of pure curiosity. They invented it because they needed to know where their god was was going, and in doing so, they stumbled onto one of the most important mathematical concepts in all of human history. The Great Pyramid of Giza was built to align with the North Star, which at the time of its construction was not Polaris as it is today, but a star called Thuban. The Egyptians understood that the night sky shifts over time due to the slow wobble of Earth's axis, a cycle that takes about 26,000 years to complete. The pyramid's alignment was so precise that when modern astronomers calculated which star occupied true north during the period the pyramid was built, it matched exactly. They were not just pointing at a star, they were pointing at the right star for their specific moment in history. Beyond that, the Egyptians used astronomy practically. They tracked celestial cycles to predict the annual flooding of the Nile, which was the entire foundation of their agriculture and civilization, a real-time cosmic warning system built out of stargazing. Most people learned that Copernicus figured out in the 1500s that the Earth goes around the sun. What most textbooks skip is that a Greek astronomer named Aristarchus of Samos figured out the exact same thing about 1,800 years earlier. Aristarchus, who lived from 310 to 230 BC, proposed the earliest known heliocentric theory, placing the sun at the center of the solar system with Earth revolving around it once a year and rotating on its axis once a day. He also correctly mapped all the then known planets in order of their distance from the sun. He got all of it right, but then Aristotle and the dominant Greek thinkers rejected his model, and the wrong Earth-centered model took over and stayed official for 1,400 years. The correct answer was written down, and the world forgot it. That single intellectual mistake might be the most consequential wrong turn in the history of science. Before telescopes, before universities, before science as a concept even existed, Babylonian priests were standing on watchtowers in what is now Iraq, staring at the sky and taking notes. Considered the world's first known astronomers, the ancient Babylonians erected watchtowers some 6,000 years ago to scan the night sky, map the stars and visible planets, and record their observations on clay tablets, creating the foundation for the first calendars. They invented the zodiac. They divided the sky into the 12 zones we still use today. They documented what appears to be Halley's Comet, and almost everything the Greeks are famous for in astronomy was built directly on a Babylonian foundation. The entire tradition of Western astronomy starts with these people and their clay tablets. No telescopes, no calculators, living in the rainforests of Mesoamerica, and yet the Maya tracked the movements of Venus with precision that still impresses modern scientists. So accurate were their observations that their predictions of Venus's orbit lost only 2 hours over a complete 584-day cycle. 2 hours. Over nearly 2 years. The Maya accurately calculated the synodic period of Venus as 584 days, and also recognized that 5 Venus cycles roughly equaled 8 solar years. All of this was recorded in the Dresden Codex, one of the only surviving Maya books. Their estimate of the length of the solar year was actually more accurate than the calendar the Spanish conquistadors brought with them when they arrived to destroy Maya civilization. The people being called primitive had a more accurate calendar than the people calling them primitive. I mean, I don't have to explain this, I know you guys know this, but shocker! The Dresden Codex also contains something that researchers have been increasingly amazed by the more they study it: an eclipse table. According to a recently published study, the information in the Dresden Codex predicts solar and lunar eclipses with even more accuracy and detail than previously believed. The table was updated over time as new observations were incorporated, functioning essentially as a work in progress refined across generations. That is the scientific method. Observe, record, correct. The Maya were doing formal iterative science. According to archaeoastronomer Ismael Arturo Montero Garcia, the Maya accurately forecasted about 55% of all eclipses. They observed that eclipses occur in cycles of 18 years and 11 days, what modern astronomers call Saros cycles, the same cycles modern science uses, figured out by the Maya over 1,000 years before European astronomers documented them. And the Spanish burned almost every book they wrote. So Awesome, thanks guys. In 1900, a group of Greek sponge divers sheltering from a storm near the island of Antikythera dove down looking for sponges and found an ancient shipwreck. Among the artifacts they brought up was a corroded lump of bronze that nobody really paid much attention to. Then, in 1902, someone noticed the lump contained a gear wheel, and from that moment, everything we thought we knew about ancient technology changed. The Antikythera mechanism is the oldest known example of an analog computer capable of predicting astronomical positions and eclipses decades in advance. No other geared mechanism of such complexity is known from the ancient world until medieval cathedral clocks were built a millennium later. The whole device would have fit inside a shoebox. Inside that shoebox was a system of interlocking bronze gears that tracked the sun, moon, and all 5 planets known to the Greeks. It predicted eclipses, showed lunar phases, and even tracked the schedule of the Olympic Games. You turned a crank and the cosmos moved in front of you. Researchers also discovered that the planetary calculations encoded in the device used period relations more accurate than even those found by the Babylonians, numbers that no previous research had suggested ancient astronomers knew. This thing was built 2,100 years ago, and it sat on the seafloor for 2,000 years. And when we finally figured out what it was, it completely changed the story of human intelligence. Alright guys, that has been our list for today. Thanks so much for checking it out. I've been your host today, Olivia Kozlowski, and I will see you again soon. Bye!